Clark, Director of Autonomous Driving and Safety Technology. Today we will expand upon the previous web tutorial, looking further into semiconductor packaging and necessary changes to material choices that will support the desired reliability for automotive. We will also discuss an innovative development to increase performance within a package. As previously stated, consumers have high expectations for vehicle design and the overall travel experience. Automotive continues to rely heavily on the advances offered through semiconductor packaging to achieve next-level safety and performance. We know that the latest automotive technologies put semiconductor design companies at the forefront of the supply chain, and this is a departure from the past. Car makers and Tier 1 suppliers are creating collaborations and joint ventures with semiconductor design companies to deliver capabilities and a level of reliability that was not previously available. Ultimately, the car makers need to differentiate themselves. So this is especially true for harsh environments and also the critical nature of their application. In addition, cost remains a major consideration. The mega trends of focus today are advanced safety and electric powertrains. Both put pressure on the semiconductor for reliability and performance. This will continue, but a lot of performance can be achieved through the semiconductor packages that have a history in automotive. This web tutorial will offer some insight into the lead frame package. We all know that automotive is synonymous with reliability, and anyone who has worked in the supply chain knows that cost is always a concern. Lead frame packages are a trusted technology with a long history of usage in automotive. This usage will continue to grow. To achieve the desired technology, packages require diversity in design and in function. So just like any other semiconductor package, the lead frame style supports the die and connects it to the printed circuit board for further distribution of information. Lead frame packages are desired because they're light in weight, thin in format, and they utilize a small footprint. They also exhibit good thermal and electrical properties. Their applications range from anything in automotive systems like body control through powertrain. So let's take a closer look at reliability of these packages. One concern is delamination of the epoxy mold compound. This can result from CTE mismatch or a result of moisture absorbing into the package. Moisture can diffuse into the package along the interface of the mold compound and the lead frame. This could happen during storage before build. During reflow, that moisture in the package will expand rapidly and cause delamination. And unfortunately, this can go undetected. In extreme cases, it will cause a crack. So you can imagine that the same is true in the end use. The absorption of moisture would cause further reliability issues. We want to eliminate this potential. There is a solution. Package bond is a lead frame treatment that promotes a roughening of the material and delivers a stronger bonded surface. It's connecting the mold compound to the metal. So to detail this further, let's take a closer look. We start with the lead frame. This can be copper or a copper alloy. Both will respond appropriately to the chemical treatment. When processed through the solution, a unique metal etching creates a roughened topography, but also a layer that will support chemical bonding. Both are executed in one process that is a uniform application. Each lead frame will experience the same treatment, and this furthers the consistency from package to package. So ultimately, there's an organometallic bonding with a roughness that further anchors the connection of the metal to the mold compound. It delivers enhanced reliability in storage, but ultimately in your system's end-use application. To understand the performance, a button of this plastic mold compound is cured on a lead frame. For this test, two types of mold compounds were tested, A and B in this situation, on treated and untreated samples, so treated being package bond and untreated being our control. The tool comes across the button, and the force required to shear the button is recorded. Prior to testing, the samples are exposed to MSL1 conditioning. That's 85 degrees Celsius, 85% relative humidity for 168 hours, and then put through 3 reflow cycles. For both epoxy mold compounds A and B, we see significantly higher shear forces when treated with the package bond, here, and here. A higher shear force indicates greater adhesion between the two surfaces, the metal and the epoxy. The image on the right portion of the slide further confirms the benefits of package bond. The right column shows that with package bond, moisture did not penetrate under the mold. The copper is uniform and clean. The images on the left show without package bond, the copper is tarnished, further indicating that moisture was able to reach the metal surface. So package bond delivers MSL1 reliability. But to reiterate, this enhanced adhesion is also beneficial in harsh conditions. And now that we can achieve this enhanced reliability, let's consider how to deliver increased function. Wire bonding packages are heavily used in all market segments, but we do see some limitations. First, gold wire can get costly, and it takes up a lot of height in the package to achieve the correct bonding. Also, as the number of wire bonds increase, there is a risk of inductance, and simply put, that's unwanted cross of information because the wires are so close. For power devices, there is a need for higher current transfer. In that instance, some might use copper clips, but one drawback is that the clips are limited in the I/O count due to the space that they require. So I/O count would be their number of connections connected to the printed circuit board. We propose a somewhat hybrid solution, a process that delivers increased density in the design, but will also carry more current. Think of the available space on the housing in the design of your lead frame package. There is so much opportunity that might be offered in this area. Package plate is the process of creating and activating specific areas on the epoxy mold compound for increased package function. It allows for increased density and enhanced current carrying capabilities, all adding value at the package level. Let me step you through a package build with the new technology. In both instances, we start with the lead frame and begin to build traditionally until after the die is placed. So again, we start with the lead frame, then we have a die attached material, the die is placed, and for the traditional, wire bonds are created. With the new technology, that part is skipped, and we move both samples to epoxy mold compound. After this step, we experience the more dramatic changes of the new technology. So depending on the design, at this stage, we can laser drill vias that connect to the lead frame, or simply create a circuit on the epoxy mold surface. The new technology utilizes a specific plastic for circuit design, activation, and eventual plating. We can formally plate the copper, we electroplate to fill vias and create thicker traces, another layer of epoxy mold compound for protection, and the package is complete. Now, with greater function in a thinner design. The package goes on to surface mount assembly as usual. As technology continues to advance, systems will be required to have greater reliability and function. The proposed technologies enable those specific characteristics for lead frame devices. Package bond delivers unmatched adhesion, giving you extended reliability, and also enhanced resistance in end-use applications. Package plate enables design freedom and thinner packages with increased function. Did you know that this material is already being used in automotive applications? Package bond is currently used in so many systems today: infotainment, instrumentation, body control, as well as chassis and powertrain. And package plate is being qualified for things like 5G, radar, and EMI shielding. To make advances in your technology, you will need advanced materials that match your expectations. We have over 60 years experience in all market segments. We specialize in material development, and as a leading global supplier, we take pride in having a complete understanding of the automotive market's expectations with a strong focus on enhanced reliability. I thank you so much for your time today. Please don't hesitate to contact me with any further questions, and I look forward to continuing this discussion with you.